Okay, so welcome back, and now we're going to do an example of using L'Hopital's rule in the case of infinity over infinity. Okay, so now notice that these derivatives are these are the same. So we know from previous discussions, previous videos, that we know the limit of this thing is going to be 3/2, right? If we look at the ratio when we talk about end behavior, right? So as x goes to positive infinity, this thing is going to 3/2. But let's use L'Hopital's rule and show that we get the same answer. Okay? So since this gives us infinity over infinity, which is an indeterminate form, we can use L'Hopital's rule. So let's do it. So by L'Hopital's rule, I'm going to take the derivative of the top and the bottom and take the limit of that as x approaches infinity. So what do we get? We get 3 over 2, which equals 3/2, right? So voila, it worked. Now let's look at the bottom one here. Now this is a right-sided limit, so a limit from the right. So now let's look at this and say, okay, well, as we approach 0 from the right, which means we're in the domain of natural log of x, so this is the only way we could do this. This goes to 0. Oh, I'm sorry. This goes to negative infinity. Now, cotangent, as I go to 0 from the right, what's going on with this? This is also going to negative infinity. And so I get the indeterminate form. So let's take L'Hopital's rule and write this as the limit as x approaches 0 from the right. What's the derivative of natural log of x? 1 over x. Over, what's the derivative of cotangent? Well, that's going to be what? Okay, it's negative cosecant squared. Okay, now, what happens if I approach 0 from the right on this one? Well, this goes to infinity. And what happens to cosecant squared? Well, this is 1 over sine squared, right? So 1 over sine squared, well, sine, as x goes to 0, is going to 0, so this is going to infinity as well. So we get the indeterminate form again. Okay? Okay, so now, so how do we handle this? Well, let's rewrite this. And so this I'm going to write as 1 over sine squared x, and so this is negative. And then this is going to equal the limit as x approaches 0 from the right. Now, since these are both reciprocals, I'm going to write this as negative of what? Sine squared x over x. Okay, now, notice as I approach 0 on the right, I get what now? I get 0 over 0. So guess what? I'm going to apply L'Hopital's rule again. So sometimes you have to manipulate things because, again, I wouldn't want to take the derivative of this thing again, the way it is. Okay? So if you see something like this and it's like, ooh, what's the derivative of secant squared? I wouldn't want to do that unless you know that how to derive that, or if you know that off the top of your head. So just rewrite things until you get something that you can use. And notice that I get an indeterminate form. So let's use L'Hopital's rule again. And so now I get what? The limit as x approaches 0 from the right. Now this is going to use the chain rule up here. So it's going to be the derivative of sine, or the outside function. So it's going to be 2 times 2 sine x times the derivative of the inside function, which is sine x, which is cosine x, over 1. Now, what happens to this as I approach 0 from the right? Sine is going to 0, cosine is going to 1, so guess what? This is 0. Okay, so that means that the limit of the original function, so the limit as x approaches 0 from the right of natural log of x over cotangent x is 0. Have a great day.